Hello everyone. In this video, I'll be discussing something about IPv4 subnetting. So I don't have any transcript, I don't have any notes with me. Let me just start up a text editor and we'll start preparing some notes and discuss about subnetting. So let me begin with writing the topic IPv4 subnetting. Okay. Now, what is IPv4 subnetting? Subnetting is a method wherein we would divide a larger network into smaller networks. Now, why do we need subnetting? We need subnetting to reduce the broadcast domains. Now, what is a broadcast domain? A broadcast domain is a logical boundary within a network where any broadcast packet is able to reach up to. The boundary where a broadcast packet will reach up to. That is a broadcast domain. Now, why do we need to reduce this broadcast domain? Well, if this broadcast domain is huge, if a network is huge and everything is in this single broadcast domain, the hosts have a tendency to generate broadcast packets for many reasons. It is a necessity in a network to generate broadcast packet for different protocols. So if this broadcast domain is huge, there would be so many broadcast packets moving around within a network. Now, the drawback of this is there would be so many packets. The network traffic would increase. The devices would be busy in dealing with these packets. What will happen is the genuine user data will get impacted. The network would face latencies, as well as the network devices would be so busy that their memory utilization will go high, CPU utilization will go high, and it would affect the network in so many ways that we would not want it to. So it is necessary to reduce the broadcast domain in order to have the network function properly. So that is why we need subnetting to reduce the broadcast domains. Now, how do we do subnetting? So that's what we'll discuss in this video. We know what is subnetting. We know why do we need subnetting. Now let's just see how do we do this. Now, before I start with subnetting, let me just write up a network. For example, we'll take a smaller network. Let's just say 10.1.1.0/24. Okay, now why did I write this as this way? We always represent IP addresses in this format. This format is known as dotted decimal format. Okay, because the block size of IPv4 is 32. Sorry, the address space, the size of the address of IPv4 is 32 bits. We divide these 32 bits into 4 octets. Octets are 8 bits. So 8 plus 8 plus 8 plus 8, 24. So when we represent it in these ways, separated by a dot, it is called as dotted decimal. And this /24 tells you about the network mask, subnet mask. The number 24 says that out of these 32 bits, 24 of them belong to network, and the rest, which is 32 minus 24, that is 8 belongs to hosts. The 32 bits of an IPv4 have two kinds of bits, network bits and host bits. This number tells you about network bits, the rest are host bits. Okay, so these values, depending on the values of these octets, we'll get to know what kind of address is this, if it is a network address, if it is a broadcast address, or if it is a valid host, depending on these values. Now, when it is 24, which means the first 24 bits belong to network and the rest 8 bits belong to host, this also means that these 24 bits will never change. It will remain constant for a network because that is the identity of that network. If these bits change, it means that it belongs to a different, it is a different network altogether. So talking about this last octet, it has 8 bits in it. If all of this is 0, it becomes the network address. If let me just first write it in binary format, that would be easier. Binary representation of 10 would be in form of 8 bits, would be 0 0 0 0 1 0 1 0, right? Yeah. And binary representation of 1 would be 0 0 0 0 1. Okay, similarly this guy, and zeros are all zeros. Let's just keep 24 as 24 itself. So this becomes the dotted binary representation of this IP address, if you will. Now among these, I said that first 24 belongs to network, the rest 8 belongs to host. These bits will never change for a network. These bits will change. Now depending on the values of these bits, we will come to know what type of address is this, whether it is a network address, whether it is a broadcast address, or it is a valid host address. Now when all of these bits are 0, it becomes network address for a /24. So 10.1.1.0 is the network address. 10.1.1. When all of these bits are 1, the decimal equivalent would be 255, right? 2 to the power 0, 2 to the power 1, 2 to the power 8, everything would be added, and the decimal value would be 255, which is a broadcast address. Okay, and everything in between these two IPs, 10.1.1.1 to 10.1.1.24 would be valid host. So let me just write that here, 10.1.1.1 to 10.1.1.254 are valid hosts. Okay, now what did we learn from this? Let's just say this is the network bits. Okay, and if I have to say if I want to talk about number of host bits, which is n would be 32 minus network bits, okay, which in our case is 32 minus 24 equal to 8. Okay, not divided, minus. Okay, that is the host bits. And what would be the block size? If I have to talk about the block size of this network, the block size would be 2 to the power n, which is equal to 2 to the power 8, that is equal to 256. Now what is a block size? Block size is all the possible values that can come in this network, including the network address, broadcast address, and all the valid hosts. So it will be from 0 to 255, which is 256 addresses, including 0 and 255. Okay, this is the block size. Now if I type 2 to the power n minus 2, that becomes 2 to the power 8 minus 2, which is equal to 254. These are valid hosts. Okay, the number of host bits can be calculated when we have network bits. 32 minus the network bits is host bits. When we have the host bits, we'll have the block size. When we'll have the block size, we will need this block size, and we'll also need the number of valid hosts. Now why did I write these things? We'll get to know. Now let's just say I have a requirement. My requirement is I have been given this network 10.1.1.0/24, and I have been asked to perform subnetting on this network and to create subnetworks. Now my requirement for subnetworks is, let's just say I want to create 3 subnetworks from this network. Let's just say for computer students, I need a network which would require 50 computers in it. For IT branch, I need similar 50 computers, and let's just say for teaching staff, I need, let's just say 100 computers. Okay. Now, when I have such requirements and I have been only given this network, I can assign everyone in the same broadcast domain and they will all have an IP address from this network. But that is not my requirement. I don't want them to talk to each other in the same network. I want them to be belonging to different networks. So that is when subnetting comes into picture and I have to divide this network. So let's just see how we will divide this network. Now, when we have such a requirement, what we have to do is we have to go in descending order. You will get to know why do we have to go in descending order. First, we'll see which is the maximum, which is the largest network. The largest requirement is the stuff with 100 hosts. Now, looking at this network, let me, I said that 24 of them belong to network and 8 of them belong to host, which means the block size has become 256 because of 2⁸. Now, if I have a requirement of only 100 computers to be in one network, I have to reduce this block size. Okay, understood? I have to reduce this block size because I only want 100 of them in one network. If I have all the 256, I'll be wasting so many IPs, and I only have this much of IP, so I have to use them accordingly. Now, how can I reduce this block size? I can reduce this block size by reducing the value of n, right? What is the value of n? Value of n is 32 minus network bits. Now, if 32 is constant, 32 will never change because the IPv4 itself is of 32 bits. 32 bits will never change. So we can change the network bits. If we increase the network bits, the value of n will decrease. So if I assign bits from host bits, if I assign bits to network bits, this number will increase and n will decrease. If n will decrease, the block size will decrease, right? That is what I want. I want a smaller block size for subnetting. Now, let's just say I have this network, and of these networks, the first 24 belong to network bits and the rest 8 bits belong to host. Let's just say this bit, I assign 1 bit from host bits to network bit. What will happen? Let me copy this here. So I said that we'll first start with staff's requirement because their network is the largest. So I just copy pasted this down. If I assign this bit from host bits to network bit, the number of network bits will become 25, and the first 25 bits will not change for this network, right? Because that will now become the identity of this network. Okay. Now, when I assign 1 bit from host to network, the number of possible values for this 1 bit is, there are 2 possible values, right? It can either be 0 or it can be 1. When it is 0, it is this network. When it is 1, it will become another network, because as I said, for a single network, this thing will never change. If it changes, it becomes a different network. So if it changes to 1, it becomes a different network. Okay, let me just write it in terms of decimal. 10.1.1. If all the numbers are 0, the decimal equivalent is also 0. /25 is as it is. For another network, it is 10.1.1. What is the decimal equivalent of this binary block? It is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. 2 raised to 7 is 1, which means 128. 128 plus nothing. So it is 128/25. Okay. Alright. So what we saw is if I assign one bit from host to network, by assigning one bit from host to network, a network got divided into two subnetworks, right? Because one bit can take two possible values. So there can be two possible networks if one bit goes from host to network. Similarly, you can imagine if I assign 2 bits from host to network, the possible values for these 2 bits would be 00, 01, 10 and 11. So there are 4 possible values, which means there would be 4 subnetworks, right? So if from 24 I give 2 bits to network, the 24 will become 26 and there would be 4 subnetworks of 26, right? When I gave 1 bit, there became 2/25s. When I give 2 bits, there would be 4/26. Similarly, when I give 3 bits from host to network, there will be how many? So this would be /27. The possible values for these would be 8 possible values, right? Because the 2 to the power 3 is 8. So there would be 8/27 networks from a /24. So the point I am trying to make here is, if someone asks you how many /28 networks are present in a /24 network, let me repeat that question. How many /28 networks are present in a /24 network? What you need to do is find the difference between /28, 28 and 24. That will tell you how many bits from host to network have been assigned. So 28 minus 24 is 4. So we have assigned 4 bits from host to network. The possible values would be 2 to the power 4, which is 16, which means there are 16 /28 networks in a /24 network, right? That holds true for all the possible values. So I am taking a smaller network, playing with only the last octet. There can be bigger networks, larger networks that belongs to these 3 octets. So the numbers would be smaller than 24. It would be 23, 22, 21, 22, and so on. So the logic remains the same. Alright, so we just take the difference and we'll get to know how many subnetworks of that size belongs to the larger size. Alright, coming back to our requirement. So what we did is we assigned 1 bit from /24 and we got 2 /25 networks. Now here what we will do is, so the block size of this, let's just consider this the first network, 10.1.10/25. Okay, in this network the network address is 10.1.1. The very first IP is 0, so this becomes the network address. What is the broadcast address? 10.1.1. The last address in this would be, now let's just see what will be the last address in this. I said that this is /25, so the first 25 bits will never change. Okay, what will change is the last 7 bits. Now what would be the last value of the 7 bits? All ones, right? If all these values are ones, that is the very last value, right? After which it will take this value. Okay, so when all these 7 bits are 1, the decimal equivalent would be if you're saying 127, that is right. Okay. Alright. You can just do the math. It is 2 to the power 0, 2 to the power 1, and so on. You know how to convert binary to decimal. Okay. So the broadcast address would be 10.1.1.127. Now valid hosts would be everything in between. Everything between .0 to .127 are valid hosts, which are 10.1.1.1 up until 10.1.1.126, because 127 is the broadcast IP. We cannot use that as a valid host. So what we saw here is we have around 126 IPs that can be used. Now, yes, what you can see here is we are wasting some IPs. Our requirement is only of 100, but we have assigned a block size of 128, which gave us valid usable IPs of 126. We are wasting 26 IPs, but there's nothing we can do about it, because if we, as we saw earlier, if we assign one more bit from host to network, the block size will reduce to less than 100, which we not want. Okay, which we don't want. Alright, so we are done with the first network. The first network would be this, which will be assigned to host, and the network address would be this, broadcast address would be this, the valid hosts would be this. Now let's just come to our other requirements. Okay, computer and IT. Now their requirement is of block size of 50. Now what we are left with is this 10.1.1.128/25, which is this. Let me just copy this. Alright, so this is what we have now, and its decimal equivalent is this. Okay, excuse my typing. Okay, now our requirement is COM 50 and also IT 50. We'll just take one by one. Okay, now computers is 50. Our block size is 50. What I have here is block size of 128. Okay, /25 means these bits will never change. Now if I use it directly as 128, I'll be wasting so many FIPs, which I don't want, because I have to create one more network for IT. So I'll reduce it further. To reduce it further, I will assign another bit from this guy from host to network. So what will happen is I will make it /26, and I'll say that all of you belong to network. So these bits will never change. 24, 25, 26. These 26 bits will never change for this network. Okay, which means, again, it means that this bit can take two different values, right? It can be 0, it can be 1. If it is 0, it is this network. If it is 1, it is another network. If this guy is 1, it is another network. So the similar values would be, so the decimal equivalent of this is this, as it is. We just borrowed one bit from host to network. The network address will not change, only the mask will change. Now here what will change is here 10.1.1. What will be the network address of this? Just calculate, just have the decimal value of this. What is the decimal value of this? 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. 2 raised to 7 is 128, 2 raised to 6 is 64. 128 plus 64 is 192/26. Okay, so we have these two subnetworks from /25. Right, we had this network, we borrowed one bit from host to network, and we have these two subnetworks. Okay, now let's just calculate the first IP, last IP valid hosts for this network. this network here, okay, because we want to assign it for computers. So the network address would be 10.1.1. The very first IP, 128. Okay, the broadcast address would be 10.1.1. What is the last value for these things? Remember, it is 26. So these values will never change, including this 0. The 0 will not change. What will change is these 6 values. If all of these are 1, the decimal value would be, the binary would be 1 0 1 1 1 1 1 1. If you calculate it, it is 191. Okay, and the valid hosts would be everything in between, 10.1.1.129 to 10.1.1.190. If you calculate, it is around 62 IPs, including 129 and 190. So there are 62 IPs that can be assigned to hosts, which is greater than 50, right? So again, there would be 12 IPs that will not be used and it will be wasted, but there's nothing we can do about it. Okay, yeah. So we are done with computer as well. Now we are left with this network. What is the block size of this network? They both are equal networks, right? /26/26. And the block size of this is again 64, which will have 62 valid hosts, which we can use for IT. So let's just write it down as it is. For this network, my requirement for IT is 50. The network address would be 10.1.1. The very first IP, which is the IP itself. Network address 10.1.1.192. Broadcast address would be 10.1.1. Again, let me just copy this as well, just for the sake of understanding. Now, if I said that these values will not change, what will change is these values. Okay, if all of these are 1, the last IP is all ones, which is 255, right? And if I talk about valid hosts, everything in between is valid hosts, from .193 to 10.1.1.254. If you calculate, subtract these things, including 193 and 254, it is 62 IPs. So the block size would be 64 and assignable IPs would be 62. Our requirement is 50, which is good. So as we can see that we had this network of /24, we created one network of /25, which was this one, and we assigned it to staff. We created 2 networks of /26 and we assigned them to computer and IT. So the block sizes used were 128, 64 and 64, and we assigned respectively the networks to all these departments. So yes, I think that's what I wanted to talk about for subnetting. I know that this is a very small network that I used, but it is easier to begin with. It is easier to understand what subnetting is. Yes, you can practice it for larger networks also. The concept remains the same. The only thing would be the block size would be increasing, and you will be playing with different octets. I played with the last octet because it was 24 and lesser. If you move further to the left, the number will keep on reducing, which means there would be less number of network bits, more number of host bits. The block size will increase, the broadcast domain will increase. So if this was /8, all these 3 octets would belong to host. only the first 8 bits will belong to network, so it would be a much larger network. So similarly, you can understand if you keep on playing with the respective octets, the block size will keep on increasing and the broadcast domain will keep on increasing. So I hope this was informative. You have gotten some idea of what subnetting is. How do we create subnetworks? We go by the descending order of the requirement, the largest the first, because you can see the logic. See, if I would have created smaller networks initially, I would not have been able to create this network, because I would have already assigned more number of bits to network and I would have left with smaller networks, so I would not have been able to fulfill this requirement. So when we are creating subnetting, when we're dividing a network, go with the descending orders. Work for the largest network first and then go for the smaller networks one by one. Alright, that's all what I wanted to discuss. I hope this was informative. If you have any doubts, anything that you want more clarifications on, please add a comment and I would be more than happy to clarify those doubts. Thank you very much for your time and patience. Have a good day. Take care of yourselves. Bye-bye.